today we're going to talk about predicate calculus. So a predicate, we mentioned before that a statement that actually depends on some other values can't be a proposition. We can turn it into a proposition if we notate it like a predicate and if we give a value to an input variable. So a predicate is a function that becomes a proposition whose output depends on an input variable. So for example, I have P of x, where x comes from some person in class. That would be my universe of discourse, so that's where I'm pulling my variable from. And P of x can be equal something like x drives a Porsche, and I'm trying to have the letter match with something in the sentence so I can remember it. Kind of like when we write programs, we like to have the variables actually have names that we can associate with things. So when we read them later, we'll know what they are. But right now, P of x is not a proposition, right? Because x is not an actual person. X is a placeholder for a person. So until I actually do what's called binding that variable to a value, P of x is not a proposition. It is a function whose output is true or false. So once I actually know what the input is, it can be a proposition. Right? So P of Dr. Barnes can be a proposition. Right? I'm a person in this class. I don't drive a Porsche, so P of Dr. Barnes is 0. Probably nobody in here does. Does anybody drive a Porsche? Even a borrowed one? That would be cool. Anyway, okay, so we actually know that no one in the class drives a Porsche, right? Is the statement that no one in the class drives a Porsche, is that a proposition? Is it true or false? Yes, it is. No one drives a Porsche is a proposition. So even though x drives a Porsche is not a proposition, I can actually make some propositions with it. So if I talk about how many times a predicate is true or false, I can actually make that statement about how many times it's true or false actually can be a proposition. And we're going to show you how to do that. But just to be more specific about predicates, we're going to do a little bit more. But like I said, our propositions, our predicates don't become propositions until we bind them to particular values for the inputs. Okay, so we're going to look at a couple of examples just from regular math. So here's our first example. And like I said, this example is given to you in your packet also. So let's consider the idea that P of x is equal to the statement x squared is greater than x. And that scribbling on the right, this x and the weird-looking e and the r, means x is in. So this is a membership symbol. And this means the real numbers. And real numbers are regular numbers. They're basically not imaginary ones. So any decimal number or that you can think of, that's what that is. Okay, so we want to know, is x squared greater than x true for all real numbers? Or is it true for any particular one? So P of 0 actually says what I do is I take that 0 and I put it in for x. And then I have a statement that I can evaluate whether it's true or false, right? So is that true or false? Great, that's false. So P of 1, it's going to be 1 squared greater than 1. Is that true or false? False. Two squared greater than 2? True. Okay, so we've actually found out that this is sometimes false and sometimes true, right? So I actually have two different ways to write that. So this letter right here means there exists. So the way I read this is there exists an x so that P of x is true. And I can plug in, so I can say there exists an x so that x squared greater than x is true. So since p of x is equal to that, I can substitute in, just like I do in my logic stuff. So if two things are equal, I can substitute one for the other. So is this a weird sentence to say in English? Okay, so any answer is correct there. It is weird for regular people to say when you're standing in the hall talking to them, right? So, but it's not weird in a math class. Okay? It's not weird in a math class because you've probably seen your professors write these and they probably didn't even bother telling you what it was. Okay? So you see them in math. It is a weird way to talk in English. What we normally say in English is we'll use the word sum or a. So we have articles that we use for that. So I could say, I know a guy who has a car. Right? That's normal, regular English. But I'm saying the same thing, right? There's a guy that I know that has a car. There exists a guy that Dr. Barnes knows that has a car. Right? So we have shorthand and we have things that we assume about how people talk. But if I hear a or I hear some, both of them mean there exists or a few. A, some, or a few. Or any. All of those are words that actually mean there exists. So if you hear any of those, then you actually know that if I had to start translating this into predicate calculus, I can actually do it because there exists actually covers almost everything that anybody says. Or the opposite of it covers almost anything that someone would say, right? So earlier in class, we figured out that no one drives a Porsche, right? Okay, so can I write that statement with our new quantifier? This is called a quantifier. Can you write the statement, no one drives a Porsche with that? There does not exist a person, X, so that X drives a Porsche, right? So where do I put the not? Before or after the quantifier? Great. It comes before. Okay, so this is, for our previous statement, that is, no one drives a Porsche. For our prior value, of P of X. So I'm glad you guys figured that out. So you got to be really careful what nots are. If the not were actually in front of the P of X, what would the sentence be? There is a person who doesn't drive a Porsche. That's obviously true, right? So how would I write it in regular English? Well, let's write it in math. There exists a person who does not drive a Porsche. Okay, that's weird. And that would only be on Big Bang Theory, right? Oh, that was a delayed reaction. Okay. Okay, so there exists a person who does not drive a Porsche. Now, if you were talking with people, you'd probably say, not everybody drives a Porsche. Right? That's much more likely for you to say. Like you're talking to somebody, blah, 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 blah. You're like, not everybody drives a Porsche. You would totally hear that, right? Okay, so these two things are equal. But they don't look like they're equal, do they? But there's a not in there. And remember that tricky knots make things into lies, right? So the opposite of there is a person is not every person. So the opposite of there is not every. Or not any. So there is a person who does not drive. So if there exists and they're not, then that's the same as not everyone. So we're going to look at that some more later. So I just want to introduce that into your brain, and then we're going to do some other math ones, and then we'll come back to the English.